Good afternoon, everyone. Welcome back to the third CoffeeShop Astrophysics talk of this semester. If you have any talk suggestions or topics that you want us to present, you can reach out to us by through our website, and you can scan the QR code here. That will take you to the website. If you are new here, before that, if you will be in Madison next week, then check out our friends who organize Astronomy on Tap, and they also have talks just like ours. So you can check them out on November 18th. And if this is your first time here, we are CoffeeShop Astrophysics, a group of graduate students and postdocs from the Leonard E. Parker Center for Gravity, Cosmology, and Astrophysics from UW Milwaukee. And we do these public talks every semester, like every month of each semester. So the speakers for today are myself, Pratyasha, and Laila. And the topic for today is space rocks and stardust. Now, what do I mean by space rock? Well, space rock could refer to a genre of rock music, which is like a blend of psychedelic and prog rock. But unfortunately, music is not what I'm going to talk about, or we are going to talk about today. What I mean by space rock is celestial objects in our solar system that does not include the sun, the planets, or their moons. And these celestial objects often appear in the night sky and look something like this. So this is a picture of the Perseids meteor shower, and it was visible back in August. And you can see here, they look like these flashing lights that are like moving very fast. Now, this is a picture taken in long exposure, hence you see these streaks of lights. But you won't necessarily see them like this, but they will appear as like ball of like fireballs kind of moving in the sky very fast in the backdrop of the static stars. And humans have been seeing these flying balls of light in the sky for centuries, as is evident from these different illustrations that people have made based on these encounters that they have had. And sometimes these, or a lot of the times, these rocks make landfall, and then they leave behind holes in the ground, or which we like to call them as craters. For example, we have the Barringer crater here in Arizona. This is said to have been formed around 50,000 years ago by a 160 feet wide rock that fell from the sky. And this crater has a diameter of about 0.7 miles. And then we also have the Pingualui crater, which is in Quebec. And right now it's filled with water and it's like a lake. But this is approximated to have formed around 1.4 million years ago, again by a meteorite crashing on the surface. And the lake that is formed in this crater is considered to have one of the most purest water out of all the freshwater lakes in the world. Then we have, in a more recent times, we have the Tunguska event, which happened in Siberia, a very remote part of Siberia in 1908. And it's believed that this was a meteorite that exploded about 3 to 6 miles above the surface. So instead of a meteorite impacting the surface, it exploded above ground. So there's not really a crater, but that explosion left the shock wave that explosion caused flattened a lot of trees around, like in a 830 square mile area. Now, there's been a lot of wild theories regarding what exactly this was, even though the meteorite impact theory is the most believable one based on evidences. But there have been theories like this was some bomb test that the Russian Empire was doing back then, or even wilder ones like it was matter and antimatter collision, which caused this explosion because there's no trace of any meteorite that's been found yet. There's also another theory which states that it was a black hole that apparently passed through Earth, and this is where it entered Earth and left behind as an explosion, and then it emerged out of the Atlantic Ocean. So several wild theories, which you can find out yourself on the internet. There's not enough of them. And then last but not the least, we have an event that is believed to have wiped out the asteroids on the surface of the Earth. And this is the Chicxulub crater in the Yucatan Peninsula in Mexico. And this crater is actually submerged. It's not really visible like the craters that I've shown you before. But the story behind it, the way it was found was there's this oil company in Mexico, a state-owned oil company, and they hired two geologists to figure out. So this was formed 66 million years ago by a 6 mile wide asteroid. And the oil company, they hired these geologists to figure out, like, in this area, survey this area for like finding out any potential oil fields. And they noticed that there's this geomagnetic anomaly in this area, like the gravitational field and magnetic field measurements were kind of weird. And that led to the idea that this could potentially be a crater that's kind of submerged in this region. And then, now, I'm sure some of you might have had nightmares thinking, like, what if a boulder, a huge boulder, is moving towards Earth, and someday it might collide and then wipe the humans off the surface of the Earth, just like it did the dinosaurs, right? I mean, I sure did when I was a kid. But so what do we do back if that happens? Do we send Bruce Willis again to like drill a hole and blow up the asteroid? So before we go into talking about this scenario, we first need to figure out where these rocks are coming from. And the answer to that lies in the history of our solar system, or to be more precise, the formation of our solar system. Now, the solar system was formed about 4.6 billion years ago, and the earliest, like the most widely accepted theory for its formation is the nebular hypothesis, which was proposed in 1755 by, surprisingly, Immanuel Kant, of all people. And based on all the observation of planets that we've had since then, like their orbits, their rotation about the sun, the modern variant of this theory is the solar nebular disk model. So what is the solar nebular disk model? So the theory states that our solar system, before it was formed, there was a nebula that existed in this place. Now, what is a nebula? If you've been to our previous talk last month, you would know what nebula is. If you weren't there, then you can check out the video of that talk. It's on YouTube. But as a short answer for now, a nebula is a cloud of gas and dust. Most times they are remnants of a star that exploded and then ejected all its matter into space. So we have a nebula, and then the gas and dust that's in the nebula, they started to come together under the force of gravity to form what is called a protostar, which is like a precursor to a star. And as the protostar was formed, matter around it moved around in a circle, like swirled around it, and then that entire gas cloud shrunk into a rotating disk called a protoplanetary disk. Now, as the protoplanetary disk rotates, the gas condenses, it cools down, it condenses into liquids and solids, and those liquids and solids then start to clump together to form what are called as primordial rocks. Now, over time, these primordial rocks also come together under forces of gravity, and then they build up into these large shapes, big enough that they can form a sphere or a round shape like planets, and these are the planetesimals. These planetesimals, over time, they collect or like they absorb all the debris that are in their orbital path, like as they're moving around the central protostar, and they become bigger and bigger to form planets. Now, this is a very interesting picture of exactly what I said happening. And this is like the first direct observation of this kind of an event. And this is a very new result. It was published back in September of this year. So if we had given this talk last year, we wouldn't have been able to show this to you. So what you see here is there is a star at the center, which is blacked out. And then on the sides, you see these rings, gray, white colored rings. These are essentially these primordial rocks that are rotating around that central star. And here you can see there is a new planet that is forming, and this planetesimal is essentially, as it goes around, you can see that this section of this ring is dark, which means it has cleaned up all the debris in its path around the orbit. So it's basically the smaller debris are colliding with the planetesimal as it moves, and it grows bigger and bigger in size, and essentially ends up as a planet. So we have a planet, but you can see that there are other rocks that are around it as well. So not the entirety of this system is like devoid of these debris. So a lot of these planetesimals don't end up forming big planets because they are moving around, they collide with each other, they break down into smaller and smaller fragments, so they remain as rocks floating around that central star. And in our solar system, there is one such region, which is the asteroid belt. Now, this is a region which is located between Jupiter and Mars. These white dots that you see is essentially the asteroid belt, and it's at a distance of about 204 million to 297 million miles from the sun. And because of the presence of a huge planet like Jupiter, Jupiter's gravitational force prevents these rocks from, clumping up and forming large planets, because the gravitational field perturbs their orbit. They move around from their orbital trajectory and then collide with each other, essentially staying as these rocks in the solar system. Then we have the Kuiper belt. This is another such region of rocks which is situated beyond the orbit of Neptune, and it's at a distance of about 2.8 to 5.1 billion miles from the sun. And in this region, the rocks that are present, because it's very far from the sun, the temperature is very low. So the rocks that are present in this region are largely icy, made of ice. And there's also a lot of dwarf planets in this Kuiper belt as well. And also the orbit of Pluto also passes through this Kuiper belt. And then, so this is another region where these rocks are present in our solar system. And then there is another region which is farther beyond. We don't have any direct evidence for this one. This is called the Oort cloud. It's a hypothetical region that's out there we believe that it exists beyond the solar system at a distance of around 86 billion to 9.3 trillion miles, which is very far. It's kind of halfway between our solar system and the closest star to our solar system, which is Alpha Centauri, as you can see here. So this is Alpha Centauri, this is the Oort cloud, and then these are all the planets in our galaxy. Voyager is here. So this is, now unlike the asteroid belt or Kuiper belt, which are like rings around the sun, or to be more precise, they're like donuts. Instead of just flat rings, they're like donuts which are around the sun. The Kuiper belt is a sphere. It's imagined to be a sphere, like it's on every side. So these are essentially, like these three regions that I've talked about are the sources of these rocks. Now, while talking about my section, I mentioned words like asteroids, meteors. So you might be wondering what they are. Are they different? Are they the same thing? So what are they? So for that, we have to know what these rocks essentially are, and for that, I'll pass it on to the next speaker. Thank you.
Is this, yeah. Hi, I'm Pratyasha, and today I will be talking about all of these rocks that we see in the night sky. Now, he has already talked about where they come from, so I will talk about how they look like in our night sky. So this is an image of a comet. When our ancestors first saw things like this in the night sky, they thought, whoa, it looks like a star, but as if it just has a lot of hair. So that's how the name comet came to be. It just means hair in Greek. Just by looking at this picture, you can already see that there are so many things going on, right? There is this fuzzy blob-like structure, and it looks like some gas kind of things are coming out in one direction, some other things are coming in other direction. So let's look at its structure in more detail. So these comets are coming from, as Tamal mentioned, like the outskirts of our solar neighborhood, where the conditions are just right to have frozen ice, frozen gas, and rocks and dust. So these are known as these dirty snowballs in sky. So it has like this nucleus that has all of the material in it, and as it comes closer to the sun, the material starts getting heated up because of the solar energy. And in this process, all of this frozen ice, they start evaporating and becoming gas in a process known as sublimation. And all of this gas kind of makes this atmosphere around this nucleus that is shown here as this fuzzy coma-like structure. And then the solar energy is also pushing at all of this material. That's why when the comet is coming closer to the sun, you can see that because of the solar wind that is like made up of the charged particles, it is kind of ionizing all of this gas, and it kind of makes this ion tail. And all of the dust, they also get pushed away by this solar energy, but it's not as strong enough. So that's why you see like these two different kind of tails, one for the ions and one for the dusts. So if we look at this orbit, it mostly follows like an elliptical path around sun. And as it comes closer to the sun, the more material is now evaporated, and then you see these tails becoming longer and longer. And then, as I mentioned before, these charged particles, they always point away from the sun. So that's how you see these ion tails to be pointing away from the sun in this orbit. And then the dust is not as bothered by it. Therefore, it follows like a path that is very close to the comet's orbit itself. This is the same image of the comet that I showed you before. This is known as comet Hale-Bopp, named after its discoverers, Hale and Bopp. And now you can like point out all of the details in this image. You can see the dust tail, you can see the coma, you can see the ion tail. This is one of the brightest comets that was ever seen, and that's why it is also very well studied. It was like appearing in the night sky for around 18.5 months. So we have very cool pictures of it now. This is another image of the same comet. Here, the very big blob-like structure, bright one, that is the comet. And then you can see some other objects also in this picture. There is this object that is pointed as 1. So the person that took the image, they claimed that it looks like a flying saucer that is just closely following the comet itself. And then because we are always interested in knowing about alien civilization and like what else is out there, it got a lot of media attention. People were like really interested in, oh, there is an alien spaceship in our neighborhood. So that actually led to 39 members of this cult known as Heaven's Gate take their lives so that they can like leave their bodies here on Earth and join these aliens in their alien spaceship. So this kind of got me thinking, like whatever claims we make and whatever like scientific discoveries we make, it has to be backed up enough, because later on this was found out to be just a star that we see a lot of. So yeah, it just has a lot of impact on the lives of humans here on Earth. This is another popular comet known as Halley's Comet. This was the first comet that was known to be appearing again and again in our night sky. So this is an image of this comet that was taken, made into a tapestry in the year of 1066. And then here you can see that there are so many people like pointing at this giant fireball in the night sky. This is the representation of it. And now with our fancy cameras, we can see images like this, which shows much more detail and the comet-like structure more obviously. So this is like orbiting sun, again appearing every 75 to 80 years in our night sky. The next time it will appear again in our night sky is going to be the year of 2061. So mark your calendars for that one. This is another interesting comet known as Comet Shoemaker-Levin 9. This is also named after its discoverers, and it's the 9th object they found, so 9. Instead of seeing one giant blob, now you see like fragments of it, specifically around 21 fragments that was like well seen. When it was discovered, we saw that it was already in a close orbit to our one of the biggest planets in our solar system, Jupiter. So we think that it was like a comet that was going around sun, but it kind of came close to Jupiter and now got like pulled by its gravity and got fragmented in this process. And then we actually saw that all of these 21 fragments crashed into the southern hemisphere of Jupiter. And it left marks that was visible for like months. So this is the first ever record of humans observing two solar system bodies colliding with each other. And that also got us thinking like, poor dinosaurs, they didn't survive. So we should do something about ourselves, because it's fine if it is Jupiter because it's far away, but we need to kind of look after ourselves. So this is another interesting comet. Initially, it was like designated as a comet, but later on, we found out that it is not actually originating in our solar system. It is coming from a solar system that is not ours. Because of its shape, and it is also thought to be an alien spaceship. People named it Oumuamua because it was discovered by Hawaiian telescope, and it means first scout. So like, the first ever try to reach us by aliens, if it is. But it is also found out to be a comet, but interstellar in origin. So if you look at its orbit, it looks like it came close to the sun, and because of sun's gravity, it got slingshotted in a way that it will never even come back to our solar system again. Recently, there has been another interstellar comet that has been discovered. It's known as 3I Atlas, third interstellar, and Atlas is the group of telescopes that discovered it. And then again, people are saying that, oh, this could be an alien spaceship. There are some reasons for it, specifically because it's showing some weird behaviors that we haven't commonly seen in other comets. So I will just take you through some of these unusual properties, I guess. So first of all, it is very bright in the night sky compared to the other interstellar comets we have seen so far. That's why many ground-based observatories are like pointing up and like taking its pictures, so we can study it in more detail. It is also moving very, very fast in our solar system. And its orbit took like a path so that it's very much aligned with where sun and all of the planets are in a plane. So it came close to many planets like Mars, it came close to sun, and also like it will come close to Earth. So that also got people thinking, oh, it has to be alien spaceship because it's coming close to the planets and taking pictures or something. But that's not true again, because it's just like following a path that would be determined by naturally following an orbit around sun, I guess. Then there has been some recent pictures that was taken. Here, contrary to the other pictures I have shown, so the comet is the big blob. And then you can see that instead of like two distinct tails, it looks like there are like multiple tails that are coming out. If I can point, yep. And then they also identified something that looks like an anti-tail. So that again got people thinking that, oh, this could be alien spaceship, but we have also seen similar like structures in other comets. It's nothing new so far. So another interesting fact about this comet is that it was like formed, we think it was formed around 7 billion years ago. Our solar system formed around 4.5 billion years ago. So that means this comet could be even older than our own solar system. Again, we also have found some higher fraction of carbon dioxide ice compared to other comets we have seen so far. So that gives us a chance to like study these objects that are like formed even before our solar system has started, and also around other solar star systems that is not our own solar system. This has got a lot of attention from media, and therefore now even Kim Kardashian is invited to like join the research team. But so far, all of the evidence is point it towards being an interstellar comet, not an alien spaceship. So let's talk about now asteroids. These are the other kinds of space rocks. These, as Tamal mentioned, they are formed much closer to the sun. Therefore, they have less ice in them. And then most of these asteroids are found in the asteroid belt, which is like between the orbit of Mars and Jupiter. So these asteroids, they can be rocky, they can be metallic, and they are very irregular in shape. You see some asteroid that looks like this weird banana-like, and then there are some asteroids that look like this weird potato kind of shape. And then their size also varies a lot. They can be from 6 feet to around 550 miles in diameter. So the first ever asteroid that was ever found is named as Ceres, and it is 1/4 the size of our own moon. And so because it is like very round in shape, and also it is like asteroid, so it is orbiting sun, so it already satisfies two criteria to be a planet, but it doesn't satisfy the third criteria, that is like it should gobble up enough matter in its orbit to clear out the orbit. That's why, even though it was initially classified as an asteroid, now we call it a dwarf planet. So the more objects that we discover, the more we know about our own solar system, and the more we are like astonished by these objects in the night sky. So far, we have found, I think, 1,473,868 asteroids so far. And if you look at this image, this is only showing asteroids that are like near Earth. And you can see kind of like, oh, it's everywhere. There are like so many of them, right? But actually, contrary to all of the popular science fiction movies and also like video games you might have played involving asteroids, the asteroid belt does not look like this. You do not have to like dodge and move your spaceship to go around. The asteroid belt is actually very sparse. The typical distance between two asteroids is around 10 times the distance between Earth and Moon. So yeah, the asteroid belt is very sparse. There are some other kinds of these space rocks that are around. So these are known as meteoroids, meteors, and meteorites. Even though this is very confusing names, but actually they are just the same object. It just has different names based on where they are in the sky. So meteoroids are actually these fragments of asteroids and comets that are just floating around in the night sky, in space. And if they happen to come close to Earth and get pulled by Earth's gravity, then they look like this bright streak in the night sky. It's because they are moving so fast, they get burned up in the atmosphere, and most of them, they just like completely burn up in the atmosphere, and that's why it looks like a streak in the night sky. And this is an image. The left side is like an image of this meteor from Earth, and then you can also see the image of a meteor from the International Space Station that is orbiting Earth. But sometimes we see a lot of them. These are known as the meteor showers. That happens when there is like trail of debris that is left behind by comets, and then Earth happens to pass by its orbit, and then now suddenly many of these debris, they come closer to Earth's atmosphere, and then they burn up, and we see these beautiful streaks of light. The closest one is happening tomorrow and day after tomorrow. It's known as Leonid's meteor shower. So if you find a dark patch of sky and look towards east, you might catch some of these meteor showers. And then the final piece is the meteorite. That's when some of these meteors, they do not completely burn up in the atmosphere, but they make it to the ground. And that's what makes the meteorite. And then that gives us a very good opportunity to like study these space rocks in your backyard without spending $1 on it. So that's what I would invite my friend Laila to talk about. Thank you.
So yes, I want to continue, but actually I want to start by asking you to please watch the following video. Hopefully we might be able to hear something. I don't know. Okay, no sound. It's good. So this is actually something that happened and that people will able to see and hear in Russia, Chelyabinsk in 2013. So I would like you to think about what would you do and what would you think it can happen if something like this happens here in our sky, here in Milwaukee, any day. So we have already been through what these space rocks think about, humanity think about these space rocks and what they actually are. But now we are going to go through what the impacts in our lives have and how we can find them and how can we study them. Okay, so here we have the example of 3 of the largest asteroids that have actually impacted the Earth. So first we have Chelyabinsk, that is the one I already showed the video about. This was actually a rock of 20 meters in size, or 66 feet. So here you have a comparison. And the consequences of this one was actually it exploded above 18 miles above the ground on Earth. But it actually damaged more than 7,000 buildings, shattered windows, and more than 1,000 people were injured. And then the next example is Tunguska that Tamal already mentioned in 1908, when a 50 meter, 164 feet rock collided also in Russia, and it flattened 80 million trees, damaging an area of more than 2,000 kilometers square. And then, of course, the largest example that we have is Chicxulub in the Yucatan Peninsula, when a 10-kilometer or 6-mile meteorite collided in the ground that actually ended up killing the dinosaurs. So these tiny space travelers have shaped the Earth's history, but they might have shaped the future too. So, but we can ask ourselves, like, how many of these space rocks or meteorites have actually hit the Earth? And according to the Meteoritical Society, there are almost 80,000 meteorites that have been found in Earth. So here we have a map where all these meteorites have been found. And the size of the circle tells the size of the meteorite, the mass of the meteorite. The colors tell us their composition. So as you can see, meteorites have different composition. They can be stony ones, they can be stony iron ones, and they can be mostly made from iron. So stony ones are mainly made from stone. So asteroids that are stony, and they have some characteristics. So they will have these chondrites. There are actually visible spheres known as chondrules that have minerals. And then there are chondrites that they won't have these chondrules. However, they will show a fusion crust. So it's when the meteor came through the atmosphere, it burned up, and due to the friction, it will create this fusion crust. So thus we know they are meteorites coming from outside. So then we have the stony iron meteorites. There are a combination of rocks and metal. And they have also different characteristics. They will have these glassy olivine crystals that actually look like gemstones. And then also ones that there are from collisions between different asteroids. And so they are stony and metallic combined. And then we have the iron meteorites. They are the less common that we find here on Earth. And they are made mostly from iron-nickel alloy. And they are very dense and very heavy. And some of them then will have these Whitman-Stetton patterns. I don't know if you can see here, but there are some lines here. So they're actually traces of the metal that form these crystals. And then another type of meteorites is these ataxites. They will have a lot of nickel content, and they will be very, very massive. Okay, but meteorites are more common than we know, than we might think. So actually, according to the Meteoritical Society, there are 17,000 meteors hitting the surface of Earth each year. There are almost 50 tons of meteoritic material falling on Earth each day. So, but where can we find these meteorites? As you can see here in this pie chart, most of them are actually found in Antarctica and in Africa because they are just easier to identify on the snow or on the deserts. However, this doesn't mean that they are most likely to fall down there. They are actually more likely to fall down around the equator because, as you might know, the Earth is not a perfect sphere. It's actually more wide around the equator. So this translates into a larger area where they can fall. And also this area rotates a little bit faster than the poles. So this where these rocks can fall down more likely. And and also the asteroids that my colleagues were already talking about, they are on the same plane of rotation, right? So that's why they are more attracted towards along the equator. Okay, but can you imagine a very massive and heavy rock entering the atmosphere at almost 160 miles per hour. So this is actually 10 times faster than a bullet. So when they actually hit the Earth, they will create these intense shock waves, and then they will have some consequences. And as a consequence, they will create these craters that we find here on Earth. So currently, according to this map, we have almost 200 craters that are found here on Earth. So here are signalized on this map, and the size of the circle tells us the diameter of the crater, and the color tells us the age of the crater as well. Okay, so we know these space rocks have shaped the Earth's history, but there are actually also time capsules from the space, because they are actually remnants pieces of asteroids that are remnants from the solar system formation, as Tamal and Pratyasha were already saying. So, and then there could also be meteorites that has material pieces from the moon and Mars, so we can study this space from here on Earth. Unfortunately, they are very hard to find, because actually less than 5% of the original object actually makes it to the ground. But as I was already saying, they are more easily found on deserts and Antarctica, and actually there are researchers going to these places just to look for them. And okay, so we know they can fall down, but it will be better if we can see them from far away, right? We don't want them to hit the Earth. So according to this pie chart, we know most of the asteroids that are bigger in size. However, we barely know their smallest one. And so there are many projects going on, and there are many telescopes and space telescopes that are actually dedicated to find and look for these asteroids and comets that pass close to the Earth orbit. So one example is Atlas. You might already heard about it, but this is the Asteroid Terrestrial Impact Last Alert System. And this is a set of telescopes that are funded by NASA that are actually have an early warning system. So they can identify small meteor asteroids, so they can give us a warning several days away. But also bigger asteroids can give warnings of several weeks out. So as I was saying, there are different telescopes located around the world. Two of them are in Hawaii, one in Chile, one in South Africa, and the rest of them are already under construction. And they can see the whole sky entirely twice each night. But as for you to have an example how powerful they are, is for us to see a light of match flame from New York brewing from San Francisco. So this is how powerful they are. Another example is the Catalina Sky Survey, which is also 3 telescopes that are located in Arizona, and they are actually responsible for almost half of the total known population of asteroids that we currently know. And the main aim is to discover these comets and asteroids, but also to identify their impact risks that they have here on Earth. So here actually this is an example of 4 different images from this telescope. From this asteroid, this was the first time ever that we discovered an asteroid 20 hours before it exploded in the atmosphere and hit the ground in Sudan. So here in the right-hand side picture, you can see here on the top, this is a satellite image when this meteorite was entering the Earth. So this is crazy. I mean, and then on the bottom, we see the traces on the sky when after this asteroid entered the atmosphere. And then on the right-hand side were these people that found the leftovers from this asteroid. This is crazy to me. And there are other missions that are out there in space orbiting the Earth, but they are also looking for these asteroids and comets. And this is an example of NeoWise, who discovered 30,000 objects. And here is a movie of the progression of 4 years of the mission. As you can see at the beginning, there are less objects and asteroids that are found in comets, and after 4 years, you can see the progress of the objects that were known. And then we have another example of a mission which is called OSIRIS-REx, which is actually the first ever mission to travel to space, go to an asteroid called Venue, which was actually a potentially hazardous asteroid, collect a sample, bring it back to Earth, so that we can study its structure, and also to help us to understand how we can protect from the asteroids here on Earth. So what you might be asking, how often then asteroids can actually hit the Earth? So luckily for us, smallest ones are more likely to fall down. So asteroids from 1 meter in size, they can fall down every 2 weeks. And of course, we don't see any effect here on Earth, but bigger ones, they just from 100 meters in size, that they can come every 10,000 years. They can cause some city-scale destruction. And also bigger in size, for a few kilometers, they can have the consequences, the climate change, mass extinction, like the case of dinosaurs. So that's why we had to come with a scale. So this is known as the Torino scale, which actually tells us the chances we have that the asteroid or comet can actually fall into Earth, and how disastrous they can be. So if a comet or an asteroid is coming with 100% likelihood to come down to Earth, they actually can destroy small or larger area cities. Okay, so we know that they can come to Earth, so we need to come with some ideas of how can we stop them and how can we protect us. So I was already telling that our best defense, that the best thing that we can do is the early detection. So we want to know when they were going to hit us. So maybe we can evacuate some cities, or so we will prevent these things, right? However, we as humans, we have already reached this stage with the DART mission, the Double Asteroid Redetection Test mission, that actually already traveled through space during 10 months and actually crashed into Dimorphos, which is actually a mini-moon from a bigger asteroid that was traveling at the speed of almost 4 miles per second. And it actually impacted into this Dimorphos and actually shortening the orbit and actually deflecting it and avoiding this for coming to the Earth. So this is how far we are, but of course, as I was already mentioned, there are many, many of these objects that still we don't know and that we want to know. But I think so far we are in a safe place. Okay, so I'm going to end it here. So we are going to go to the round of questions, but we want to say that we have 2 rocks here from the planetarium, from the university, and one of them might be a meteorite. So after the talk, you might want to come and see, and maybe actually you can identify it and tell us which kind of meteorite it is. So thank you very much.